Hey guys, welcome to Nuko Maths. On this channel, we break down concepts into easy steps for you to understand. Today we're going to start with the topic of algebra and go over like terms. Here's an overview of what we're going to be doing in today's video. First, we're going to be talking about what like terms are to help you gain an understanding. Then we're going to work on some problems about adding and subtracting like terms from easy to harder questions. Third, we're going to be going over some basic indice rules. Okay, let's get started. What are like terms? Like terms have the exact same variable and power. This 3 has the variable x, and this 4 has the variable y, but this 4 has no variable, so they must have the same variable and power. So from what I've said, are these two like terms? Yes, they are, because they have the exact same variable and the exact same power of 1. Now let's try this. Are these like terms? They're not, because they have different variables, which means that they're not alike. Okay, let's try identifying how many like terms are in an equation. So in this equation that I've just written down, how many like terms are there? There are two like terms, 3x and 3x. We know they are like terms because they have the same variable x and they're to the same power of 1. The next step is to group the like terms. In this equation, let's see how many like terms there are and then group them. We can see there are two like terms, 2x and 4x. So in the line below, we put them one next to each other. Let's try it again, but with different variables. Okay, 6p plus 4q minus 9p. Let's identify the like terms. We've got two p's, and they're both to the power of 1. So 6p minus 9p plus 4q. And we group them together because they're like terms. And remember to include the minus in the minus 9. Now let's have a go with like terms with different powers. So as you can see here, we've got a lot of x's. But the difference between them is that there are different powers. The 5x squared and minus 2x squared are like terms because they are raised to the same power. But the 3x and 7x are different because they only have a power of 1. So there are two different like terms here. Here's another type of variable. It's just with the x and y together, but we follow the exact same path of grouping the like terms together in the next row below. So let's start with xy. 4xy and minus 3xy are the same, so we'll group them together. 4xy minus 3xy. We group the x's, 6x plus 1x, and then we group the last one, the 2y by itself, and it follows the exact same process. Let's try adding and subtracting like terms. We will use the skills that we have just learnt before to help us. The rule for adding and subtracting is that you can only add or subtract like terms, so they must have the same variable. So 7x plus 3x, are they like terms? They are like terms because they have the same variable of x to the same power of 1. So 7x plus 3x is the exact same as 7 plus 3. The x just carries along. So 7 plus 3 is 10, and the x just carries along. Let's try another question. 10y minus 4y. We know they're like terms, so we just do 10 minus 4 and add the y, which is 6y. Okay, here's a medium style question. 3p plus 7p minus 3q. We identify our like terms of 3p and 7p. Now the rule is you can only add or subtract like terms, and so they are like terms, so let's add 3p plus 7p, which is 10p. But the q doesn't have any like terms, so it stays the same. So now we have 10p minus 3q. Let's try another question. 9x minus 4 plus 2x plus 6. We group our like terms in the line below. 9x plus 2x and minus 4 plus 6. Now we do our adding. 9x plus 2x is 11x, minus 4 plus 6 is 2x. And we got this by putting the like terms together and then adding them as normal. Now let's try a question with powers. 4a squared b minus 2ab plus 5ab plus 3a squared b. Now it's the exact same process. Let's find our like terms. we've got the a squared, and that's different from a, so these two are like terms. We're going to write them next to each other and the normal AB ones next to each other. And let's solve as normal and just add our numbers. So we've got 7a squared b plus 3ab. Our final topic for today is laws of indices. In this video, I will only be covering a few basic ones, but in my other video, I'll be covering all of them. Our first rule is a to the power of n times a to the power of m equals a to the power of n plus m. An example of this is 2 to the power of 2 times 2 to the power of 6 is equal to 2 to the power of 2 plus 6, which is 2 to the power of 8. The only thing that's happening here is that the powers get added together. The base number should be the same. A common mistake that students make is that when they see x times x, they think, what powers do I multiply? When x is by itself, what it means is that x is to the power of 1. So if it's x times x, it'll be x to the power of 1 plus 1, which is just x to the power of 2. Let's try another example. A squared times a to the power of 4. That is just a to the power of 2 plus 4, which is just a to the power of 6. Because remember, the powers are just being added together. Let's try another example. 3x squared times 4x to the power of 3. First things first, we multiply the coefficients together, which is 12. And then we use our indice rule and just add the 2 and the 3, which is x to the power of 5. But let's break it down a bit more. The reason that we got 12 was because we multiplied 3 and 4, and we're allowed to do this because they're the coefficients. And then we did x squared times x to the power of 3, and that's our rule before, where we just add them, which gives us 5. And that is how we got 12x to the power of 5. Let's try a medium level example. Minus 2a cubed b times 3a squared b to the power of 4. First things first is we multiply our coefficients. Minus 2 times 3, which is negative 6. We multiply the a's together, 3 plus 2, which is a to the power of 5. Then we multiply the b together, which is 1 plus 4, which is b to the power of 5. But let's break it down once again. Multiplying the coefficients, minus 2 times 3, which is negative 6. Then we multiply our a's, which is a to the power of 3 times a squared, which is just a to the power of 3 plus 2, which is a to the power of 5. Then we multiply our b's, which is b to the power of 1 plus 4, which is b to the power of 5. And that's how we got minus 6 a to the power of 5, b to the power of 5. Here's another example. 5m squared n times minus 2mn to the power of 3 times n. And we see a multiply sign, so we can use our indice rule. Let's first multiply our coefficients. 5 times minus 2 times 1, which is just negative 10. We multiply all of our m's, m squared plus m to the power of 1, which is m to the power of 3. And then we multiply our n's, which is 1 plus 3 plus 1, which is n to the power of 5. But let's break it down once again. We multiply 5 by minus 2, which is negative 10. We multiply our m's together, which is m2 plus 1, which is m to the power of 3. Then we multiply our n's together, which is 1 plus 3 plus 1, which is n to the power of 5. And that is how we get minus 10 m to the power of 3 times n to the power of 5. Here are some practice questions. Pause the video and give them a shot. Now I'll go over the answers and you can compare your answers, putting the like terms next to each other. 4x plus 2x plus 3y. I put the 4x and 2x next to each other because they're like terms. 6y plus 4y plus 2. The 6y and 4y are like terms, that's why they're next to each other. Now adding and subtracting like terms. I put the like terms next to each other, 4y plus 2y plus 3x plus 3, and then I add them, 6y plus 3x plus 3. Same with the next line, 4a squared b plus 4a squared b plus 2a plus 3, which is just 8a squared b plus 2a plus 3. I'll highlight the answers in blue so you know which ones to look back at. Our final two questions. We see the multiply sign, so we know to use our law of indice. We first multiply our coefficients and we get 24. Then we multiply all of our a's, which is a to the power of 3. And then we leave our b because there's nothing else to multiply it by. So 24, a to the power of 3, b squared. Second question, we multiply our coefficients and get negative 36. We then multiply our x's and get x to the power of 6. And then we leave our y, which is just y. So final answer is minus 36x to the power of 6y. Here's a summary for today's lesson. We learned how to add our like terms together. 3x plus 4x is 7x, and we can do this because they're like terms. But if it's multiplying, we don't have to wait for the terms to be alike. They can be different. But we know our first step is to multiply the coefficients together and then our same variables together and adding the powers to give us a new number, which in this case is 3. Here's a summary of the key formulas that we learned in today's lesson. The only rule that we learned today was the adding indice rule, which is a to the power of n times a to the power of m, which is a to the power of n plus m. Thank you guys so much for watching today's video. Make sure to like and subscribe so you keep up to date with the videos that we post. Next week's video will be about the laws of indices. See you all next time.